Welcome, everyone. Thank you so much for joining us today to talk about principles of learning sciences. So at Labster, we're always talking about teaching and learning science, but today we're going to take a look at learning sciences, how people learn, and the science behind that. So welcome to our webinar. If you would like at any point to pause this webinar, please feel free to. If you want to take some notes, if you want to grab your note-taking device or pen and paper, pencil, whatever works for you. We'll have some time for reflection throughout this session as well, and we are really excited to get started with you. So today I am being accompanied by a wonderful guest, and I will just quickly introduce myself first. I am Sasha, I work at Labster, and I am in the product marketing team.
Hi there, I'm Rachel Schechter, and I founded a company called Learning Experience Design Research, and we call it LXD Research for short. And I am a program evaluator and researcher, and I've been researching media-enhanced educational tools for, I just realized, like over 12 years now. And when we think about the use of educational technology in the schools, like I really kind of was right there when it first started. Not only do I conduct efficacy studies, I partner with school districts around the country, and I also partner with companies such as Labster who are using and sending and putting technology in the schools to help enhance the learning environment. The products that I study are being used by millions of learners, not only in the United States, but around the world.
Awesome. Thank you so much for being here with us.
And I'm really excited today to tell you, to really introduce or share the history and the principles of learning sciences. So I most recently was Vice President of Learning Sciences at Houghton Mifflin Harcourt in Boston, which is where I live. It was really fun to go down to the seaport every day and see the fun history of this public publishing company, now EdTech company, and really what was so neat and talking and thinking about learning sciences is that it really is across the disciplines. It's for all ages, and it's really about how humans learn. So today I'm excited to share and talk about how Labster uses learning sciences and really how its product was founded and grounded in learning sciences principles. So I'm going to share some resources about learning science research. We're going to talk and we're going to hear from Sasha all about learning sciences at Labster. And then we're going to kind of zoom out a little bit and think about, well, what are the essential conditions that need to happen at the school, at the district, kind of in that local context that enables and supports not only learning sciences, but really leveraging educational technologies such as Labster with learners at all the way up to the macro level. And then we're going to give you a sneak peek at how you can get started with Labster as soon as today if you wanted.
So maybe to kick us off, you can tell us a little bit about what learning sciences is.
Absolutely. So it's a relatively new field. And one of the reasons why it's relatively new is because in the past 30 years, as the computer processing and the technology for understanding the brain, so neuroscience and all the achievements and advancements in that field over the past 30 years has really enabled us to understand how we learn and how the brain is connected and related to how we learn in a way that just was not possible before. Also, cognitive science as a field has also just really been integrated with social sciences and contextual science, and even implementation science is also relatively new because we're really trying to cross silos in the academic community more than we ever have before. And when we're talking about learning sciences, it's kind of this layer that's on top of the standards, that's on top of the pedagogy, that really enables equity in education. And that's another really interesting part of this. And two of the resources we're going to talk about, the first one is the Learning Sciences resource, Digital Promise. Digital Promise is actually an organization that was founded by an act of Congress here in the United States just over 10 years ago. And our leaders were noticing that educational technology was ever more present in the public school system. And they wanted an organization to really bring the research about learning to the surface and to help express and share that information, not only with the folks that are doing the teaching and learning, but also the folks who are creating those tools, right, to help support and enable teaching and learning effectively. So there's two things that they started doing. One is they did the research and they put it out there. So that's the Learner Variability Navigator. That is the tool that anybody can use. And they have it, actually it's for all ages and adults. And they did focus it on reading and math, just kind of like as an entry point for teachers. So you might want to check out the math one if you're a science teacher, especially in the older grades. And then if you're in the younger grades, you might want to check out both the reading and the math one, because your young ones are going to be focused on reading a lot as well. Reading to access the content, right? So the Learner Variability Navigator is really this interactive online experience where you can check out the different background factors that impact the learning sciences and how we learn, and then the strategies that are related to help support and moderate or mitigate those factors. The other thing Digital Promise has done is created a certification system to help consumers and school leaders know, well, which products are truly based on learning sciences and which products just say they're science-based or research-based. And I'm proud to say that Labster has earned this certification. Fewer than 1% of EdTech tools in the US have this certification. So wonderful. So excited for Labster and everybody over there. Sasha, what's been the response to this earned certification over at Labster?
Yeah, this is really, really exciting for us, for sure. I think that, there are so many up and coming tools and different ways for teachers to engage students. And so for us to be recognized as research-based is huge. And we're really excited that we are, making a difference in the way that teachers are able to engage with their students, and students are able to engage with scientific content with science-based principles, learning sciences-based principles. So it's really, really exciting to see all of the work that you've been doing and these organizations have. So thank you.
Oh, wonderful. I'm so thrilled to hear it. And then the efficacy research that you've already done and are going to be continuing to do, and I'm partnering with Labster to do that work this coming year. Though there are different review organizations for those, so another day. Another day. So the other thing I wanted to just let you know, the ISTE, the International Society for Technology and Education, which may be familiar to many of the viewers today, these essential conditions, we're going to be talking about those a little bit later on, but they really dovetail, and you'll see really beautifully with how we have the Learner Variability Navigator, really that's right, that focused on the learner and their needs, and then those essential conditions for how to enable those needs to be met from a macro level.
Awesome. So I guess, let's start with the Learning Variability Navigator. I see there are 4 colors there, the 4 factors. Can you tell us what those are and what those mean?
Absolutely. So there are over a dozen of different factors, and what they've done is organize them into categories. Again, just kind of like to help us process and kind of decide where to start. And but really they work together. They're probably, I don't think there's any strategy that doesn't address at least 2 or 3 of these factors simultaneously. But what's nice about the Navigator is that you can look at them individually. So we have the student background, and that's the little house. We have the social and emotional learning, and that's the red with the little heart. We have cognition, and that includes executive functioning, and different kind of cognitive skills that are outside of the discipline. And then we have the discipline specific skills, and that's that blue book there. So those are the foundational skills in the domain for our younger students, and then kind of like those more advanced skills that cut across domains within the discipline.
Awesome. So, I've heard of things like, auditory learners, visual learners, students learning in different kinds of ways. Does this relate to that at all? Or is that something that you have looked at?
That's such a great question. And so this idea of learning styles, that there are like 3 or 4 kinds of learners, and those learners learn better when presented with information in that way, that's actually a learning sciences myth. And the research over the past 30 years in the learning sciences field has actually shown that it's not true. It's not true that people are only one type of learner or prefer one type of learning. Instead, actually, most humans benefit from seeing visuals. Most humans benefit from having complex audio not overlapping with complex visuals, right? We need those separated, for example. But we do learn better with images and text, for example, or images and audio, for example. So learning scientists prefer, instead of learning styles, we talk about individual variability. And there's that word variability right here. So that's what it is. It's the individual variability that we want to be teaching to and using strategies for. And this is a tool that really can help you start to explore that concept of individual variability, because we hear all the time individualized learning or personalized learning. And you're like, well, what does that mean? And I think some people might just assume learning styles, but that's actually not the case. It's these factors, these research-based factors.
Awesome. Yeah, that makes a lot of sense. Even in Labster simulations, right? We do have visual aids, we have visualizations, and then we also have like auditory ways of learning, text-based, and so all of it sort of combined together. So
exactly, multimodal.
Yes.
Multimodal. That's the key. That's the key.
So yeah, I'd love to jump into some of these and see how they connect with Labster.
Great, and I picked 4 for us to explore: inquiry-based learning, project-based learning, and guided practice and worked examples. That's fine. So I picked these 4 because I really feel like they are most tightly connected with the Labster experience at every moment.
Awesome. Let's get into it.
So inquiry-based learning. So I think that these phrases might seem really familiar, but then but maybe we may or may not really know what they mean exactly. So inquiry-based learning, you kind of get like, oh, questions, that's asking kids questions, right? But it's a little bit more than just that. So I'm going to read these for us. So it's active listening. So that's going to be really bring your attention to the information, and attentive listening, right? It's going to be reflective questioning. And that's not only from the teacher, but that's also the student asking questions themselves. And I think that's one of the things that self-paced learning really gives students that space. Students can talk through their thinking. Feel like when we're in a lab situation, not everybody can just talk out their thinking at the same time. So it's another really nice opportunity where technology can help students talk through it. And when they talk through it, it's almost like they're engaging with themselves to push their learning. It's very motivating to ask a question and then try to answer a question that you have, right? Not someone else gave you, but that you have. And when you put all these things together, you can kind of see how it could develop a learner's ability to have more sophisticated reasoning skills. It can help them really build and break down and then break down and then build their mathematical thinking skills. Problem solving, kind of like, I think, challenge with problem solving, you don't really know where to start. But if you can figure out what question, if you can get used to and practice asking questions, that gives you a path to begin. And then communication skills. Self-talk is a critical practice place for communication with others. So if students are talking out their thinking and practicing their questioning during a learning experience, that then when they come into a collaborative setting or a group setting where they're going to be expressing what they learned or enhancing and expanding on what they learned, right, they're going to have that language. They're going to have that right at the tip of their fingers and potentially be able to get farther and deeper once they're in the group setting. Does this sound like something that you've seen at Labster?
Yeah, absolutely. I think, all of our simulations are sort of built in with student choice. So students can decide how they want to start their journey in their simulation. They can start by, reading the theory and getting all the background knowledge, or they can, jump right into the interactive learning activities and start answering questions right away. And I think that self-paced piece is really important in our Labster simulation. Students have the chance to take as long as they need. They can pause, go back, read the theory if they aren't really understanding what's happening, and then jump back into the activity and play the different little games and answer questions to move throughout their mission. And so we also have lab reports that students can complete after simulations and practice those communication skills as well to demonstrate the learning that they've done. And so yeah, definitely sounds like we're very much sort of incorporating this in all aspects of the way that Labster simulations are created.
Absolutely. And what you described about choice, autonomy, having a sense of pace and place are really critical to motivation as well. And that kind of environment's very motivating. The next area of strategy that really helps support and moderate a lot of those factors for individual variability is project-based learning. Now, I know when I first was learning about this, I thought that inquiry-based learning and project-based learning were the same things. I'm like, IBL, PBL, that sounds the same. And I was like, then I learned, oh no, they are not the same thing at all. Okay, so project-based learning, that's about having an authentic problem to solve. And even if there is a fantasy element of the problem, like looking into the future, the metrics or the aspects that, like the mini problems within the larger problem, those are real. That's based in really authentic and tangible, concrete challenges. And then that it's relevant to students. It has something to do with their lives, with their future, with their everyday. And then the educators in a project-based learning environment, they're really the facilitators, and they're not, this is not a I do, we do, you do kind of situation. This is a students do situation. And this combination of having a real problem that students are motivated to solve and teachers are there to support, scaffold, nudge as needed, it really develops that student agency, that also that self-efficacy that I can do this. This is something I can do. I am a science person, right? And that's very motivating, that sense of belonging and that competence. So another pillar of motivation is competence, that you feel like you can do it, that you know that you can do it, that you have the agency, the choice, right? The control of your learning is incredibly motivating. And then collaboration is just really critical to problem solving, because having diverse perspectives, right? Having different backgrounds and expertise that you're coming and bringing to a team. It sounds like adult work environments, doesn't it? Right? And learning
Absolutely.
that and knowing that as a young person is really, really powerful for their self-esteem and their understanding of their future. And then the next thing is, of course, problem solving, critical thinking. I mean, that's just right baked in, right, to project-based learning. And then communication, because working as a team, figuring out that problem, bringing your expertise and your diverse perspective out into the group. So many communication skills critical there. And then I guess one last thing I want to just point out is that all of these things need to happen in a space that's psychologically safe and welcoming for the students. So just kind of like putting that out there as a macro level.
Yeah, absolutely. What you're saying about, student autonomy, self-efficacy, safety, all of that's really important to us and, to our mission at Labster, really empowering the next generation of scientists and improving access to science education. And, our simulations are a very good representation of this project-based learning. The little GIF that I have on the screen there is from one of our simulations on behavioral thermoregulation, where students are trying to keep this fantasy animal Gexai alive based on different principles of different temperatures and energy in various habitats. And so a lot of our simulations have these sort of fun elements of being maybe on another planet or in a fantasy world, but are sort of based on scientific principles and conditions that exist in the real world as well. And a lot of our simulations also have very real, true to life applications as well. One of our simulations of, someone knocks their head and then loses their speech ability. And so trying to understand the different parts of the brain and what's causing that, students are making hypotheses at the beginning of the simulation where they choose, what they think is going to happen. And then they go through the simulation and sort of figure out whether what they were thinking was correct, or, try and understand why they were thinking that as well. And group work simulations can be done individually by students. They can also even sit in a classroom and work on a simulation together, or come back together after doing a simulation and really get some of these benefits of project-based learning. So yeah, it's exciting to sort of see how Labster aligns with this really well.
You're going to keep seeing that alignment when we talk about guided practice and worked examples. So really to help students understand, hold on. Let me just have a little sip of water here for a second. So for guided practice and worked examples, this is really where having some examples that are already completed can help students know where to start with new problems. Having that modeling of one way that it can be solved can help them build off and extend and expand on different ways that problems can be solved. Because as we know, there are so many different ways to solve problems, and maybe not even all problems have a solution, or even one, certainly not one solution, or not many different ways to get there, right? So having these worked examples is a really important part of how to support individual variability. So analyzing and discussing solved problems, and then also sounds like some of the simulations, for example, and in science, they can be really abstract, right? Or maybe a scenario that you can't have melting lava volcano in front of your, in your classroom. So to be able to provide some deep understanding to abstract concepts, right? Having those examples available to explore can really help make that, more concrete. And then reducing the cognitive load. So having an example of how something could be done can kind of help. So we only have so much mental processing. This is another part of our neuroscience, cognitive science work. So our cognitive processing and our working memory, right? It's a limited resource. It's not unlimited amount of memory that we can hold, amount of things we can hold in our memory at a given time. So because it's a limited capacity resource, some of it can be taken up by just the logistics of looking around, or the logistics of all the materials that are sitting in front of you. And that reduces the amount of resources available for that higher cognitive thinking and that higher that problem solving work. So having those worked examples can help reduce that cognitive load. Now, guided practice really kind of works with worked examples because it can help the student know where to focus their attention. And if we think about like in sports, for example, like a tennis coach, they don't just kind of practice tennis generally, vaguely. Maybe you're working on your serve. And then even if you're working on your serve, you're going to be working maybe on your wrist placement, or you're going to be working on how your shoulder is moving. It's going to be really focused, right? And that kind of practice is called deliberate practice. So focused, targeted practice on a sub skill. There are a lot of other qualities of practice that make practice more effective. For example, interleaving, which is the idea of mixing up sub skills that you work on in different orders and not always doing the same thing every single time. And space practice. There's lots of other practice. I encourage you, if you're a practice fan, to go check out retrievalpractice.org, for example, is a great resource. But what I want to focus on here is that, especially in the science classroom, having guided practice and work examples helps support and develop critical thinking. Again, you get more practice because your cognitive load is reduced. That metacognitive practice of being able to make the abstract concrete, and then actually improve self-regulation, because when you feel confident and you know what you're going to be doing, you can actually have more control over and manage your own emotions and behaviors, because you also have more resources for that as well.
Yeah, so hearing you talk about this, the first thing that comes to mind with Labster is our beloved Dr. One, who is the female AI robot that sort of guides students through the simulations, and she's there to give help to sort of be that guide. And we even, in this little image that I have here, you can see that there are like arrows that show up, and you can actually see, if you're not sure where to click, there are arrows to guide you, which sounds like that would help reduce cognitive load and really just help students focus on the mission at hand and the learning that needs to happen. And so also students are sometimes doing these simulations before they might have a practical lab experiment, and even just the whole process of going through, being guided through the steps before they're doing that live in person in a wet lab is a great way for students to also feel just like more prepared, more confident, and be able to really focus on the process and the learning while they're in the lab as well. So yeah, thank you for sharing more about that. And so I guess now we've sort of gone through those big four ones that we picked, and we're going to move into a time of reflection. So we'd love for you to, when you feel ready, you can pause this video to take some notes, get that note-taking device of your choice, and think about these questions based on what we've talked about so far. What has connected with you? Is there anything that you would like to come back to and learn more about? Anything that you're inspired to try, and also reflecting on things that you're already doing that you might be able to do more of in your classroom. So again, pause for as long as you need, and come back and join us to talk about the essential conditions. So awesome.
Okay. Oh, I'm loving what you're saying, Sasha. Oh, it's so great. I'm gonna just take one more sip of water.
Take your time. We can
edit
everything
out.
out.
Editing it out. And thank you, live audience.
Yes, thanks for bearing with us. Feel free to reflect while we're getting ready to move on. So
if you were, I'll wait till you're finished drinking, because I did, because we still have to do this one first too.
Go ahead.
Okay, ready? Okay. So if you're one of the people who were thinking, I want to come back to this, let me tell you a little bit more about the resources available for you. So digital learning sciences strategies, they're all going to be on Digital Promise, that learner variability navigator I was telling you about. Here's another list of of strategies that, again, that we ended up using actually in our application for the Digital Promise certification that Labster has earned. And if you want to hear and even more, expanding on what Sasha's already shared, check out the blog post that April and I wrote that really was inspired and taken from the application that helped Labster earn its learning sciences based certification.
And all of these resources that we're talking about will be available to you in the email that you'll receive. So don't worry about remembering everything. You will have all of those in a list for you.
If you're still thinking about, wait, where should I start exactly? We even made a checklist for you. So you'll also be getting the Labster Learning Sciences checklist, kind of thinking about, are you ready to take the next step in bringing more learning sciences into your science classroom? And there's some items for thinking about your students, and then there's some items for thinking about you as an educator in like where you might want to start on your next steps.
So yeah, let's jump into essential conditions. Can you tell us a little bit about what you mean by that and what ISTE means by that?
Oh yeah, sure. So I actually had a wonderful opportunity to consult with ISTE last year in really deepening their practice and integration of learning sciences in their framework and their standards and kind of how they do their work. And these essential conditions are 14 critical elements that are necessary is really one of the examples that they already have and is available for the public in thinking about how to support learning sciences in student learning. So we're going to actually just kind of like dovetail our learner variability with our student-centered learning. And then we're going to expand on the curriculum framework and then come back out and thinking about equity. So for student-centered learning, you can see from what we were just talking about, the students are active participants in their learning. We're meeting students with their individual needs. There we go, that word individual again, and abilities. It's really about what and how they learn. And then now because it's ISTE, now we're really bringing in that technology more explicitly. Okay, so the technology needs to be served in a way that meets the students where they are in their learning journey. And you want to just jump to explain how Labster does that?
Yeah, absolutely. So, the best part about Labster, or maybe there's no best part, there's lots of great parts, but one of the key features of Labster is, we mentioned that it's self-paced and, students are able to jump in, jump out when they want to. It's really, focused on a student being able to work on a Labster simulation whenever they get the chance to. They don't have to sit and, spend 30 minutes on a simulation at one point, but they can sort of go in and out. The questions also that are sort of sprinkled throughout the simulations are ones that they can do over and over again. If they get it wrong, shuffles the answers and they can try again. And so, allowing students to fail and make mistakes and sort of get back and stay on that learning track the whole time really does sort of center students at the core of what a Labster simulation can do.
Absolutely. So then we have the curriculum framework, and this is where, again, the technology is now being applied to support the curriculum. And you'll see that real world skills coming in again, that the technology helps make the standards, put it in the real world, right? The world of today, these standards, gosh, some of them originally could have been created like 100 years ago, right? Or more probably. But we want to bring that to today, right? Or even the future. So, and to learn the right skills at the right time for the right reasons. And that goes back to having the students be at their level, kind of like in their zone of proximal development, not too hard, not too easy, but really just that right level of difficulty to have them build their next set of skills, the next level of complexity. And then, of course, we still have to meet specific learning objectives. So while those may be the standards that are covered in a particular state or school district, it's also learning objectives that might be just beyond that, but will still help them move forward towards future learning.
Yeah, so I mean, Labster simulations are very much aligned with standards, the next generation science standards, AP and IB, but also sort of goes beyond that. It's not just addressing those skills, but all of our simulations are also related to real world skills, real world scenarios that maybe aren't necessarily covered in those standards. And so, you know, the goal is for Labster to really be that tool to help engage students and also sort of help them move along in their academic journeys. So it's also, we have, you know, over 270 simulations at this point, and some of them are probably, you know, higher level than potentially what students might have in their standards, but it allows them to challenge themselves and go beyond that in places where they feel like they would like to. And so that's another benefit, that, you know, teachers can assign specific simulations to students, and then they can also have sort of simulations that might be optional for students that want to challenge themselves and sort of go beyond as well.
Yeah, and what I and what I really love about what I'm hearing you say is that it's all right there for the teacher. They don't have to go scour the internet for things and figure out how to Google stuff. And I mean, they really, you know, it's all right there. And the information, if you're helping the teacher know, well, what is next? What would be a higher level challenge for the one that they just completed? And then you also can see how the students perform, because the students may not be in the classroom, right?
Yeah, absolutely. Everything is sort of in one place, you know, all of our simulations and also some of our other supplementary content that goes along with that, lab manuals, animated videos that, you know, help students to visualize concepts. And so teachers can access all of that and sort of assign whatever makes sense for students in the moment and in the context of their course. And so we really try and, you know, make the experience as easy as possible for teachers to find what they need when they need it to fit their curriculum.
Oh, great. I love that. And that kind of actually beautifully dovetails us into access, right? Because the teachers being able to access what they need helps reduce, hopefully, their stress, their cognitive load, right? And their limited resource of time, just a huge one. And then when thinking about the students' access, there's really two different kinds of access that ISTE addresses in this essential element, and that is the connection speed. So and the device access, right? So having the device, having bandwidth, having connection speed, where they are, right? Anytime and really anywhere that they need to be, where they need to be doing this learning. And then the other kind of access is equitable access in terms of students with special needs. So teachers to be able to know how to use the tech to enhance and make those experiences accessible, but also having potentially, I mean, ideally, the material and the technology have a universal design for learning, and having those accessibility features available to the learner as opposed to controlled by the teacher.
Yeah, I mean, both of those resonate so deeply with our mission at Labster. And, you know, when it comes to devices, we've recently expanded the support of our devices, where we have the ability for students on all Chromebooks, Android tablets, iPads to be able to download the app and play simulations directly through those devices. And so, you know, that is our hope, that more students will be able to access this and more conveniently from wherever works for them. And it, you know, with the piece of accessibility, like you said, students have the ability to turn on our accessibility features. You know, students with visual and hearing impairments have access to the text size adjustment, keyboard navigation, our very own screen reader. And so we are very much committed to making sure that all students can access this content. And, it's not just segmented for certain kinds of students or certain students, but really, really expanding that access in as many ways as possible to, truly empower students and not sort of discriminate there.
I realized I didn't mention that my company, LXD Research, is part of a larger company, Charles River Media Group. And there's this wonderful video on the Labster website that really talks about the students with special needs who've benefited from Labster. If you haven't gotten a chance to check out that amazing video that really brings to life everything that Labster has done to help increase accessibility, I definitely recommend that you check it out.
Yeah, we'll absolutely add that to the resources that you get.
Okay, so reflection time, same as before. Now kind of like, thinking about your classroom, but going outside of your classroom, what really connected with you? Learn more about, pause, reflect, take notes. All right, so ISTE really covered a wide range of topics and thinking about how to support technology in schools. And I recommend especially if you're a school level leader or a district level leader, there's a lot here. But one thing they did a really nice job with is that you kind of can click on the topic, like click on shared vision, and then it takes you and really talks about that one element at a time. So if there's a particular element that you've been struggling with or thinking about how to do something different in that area, so I recommend checking out the ISTE website on the essential conditions.
Awesome. And with that brings us to the end of our session. If you are interested in joining our community of educators, learning more about Labster, you can join our campus community for free. You don't have to be a current user of Labster. We really, really just want to connect and build this community of educators to be able to learn from each other, and for us to be able to learn from you. We know that the best way for us to build a product that meets your needs and your students' needs is to talk to you. And so please join our community. And again, you will get a follow-up with all of the resources that you need and anything that you would like to learn more about. So thank you so much for joining, and thank you, Dr. Rachel, for joining us today.
Thank you so much for speaking with us or speaking with me, speaking with all of us. And I feel like we really got a sense of kind of a deeper dive into learning sciences and a deeper dive on how learning sciences help y'all teach science.
Wonderful. Thank you so much.
Thank you.